Good morning friends, welcome back to Relief Tutorials. In the last lecture we have discussed about equations of motion, or we can say equations of uniform accelerated motion. Three equations we have derived. These three equations are, first one was V and T relation, V is equals to U plus AT. Second is ST relation, means distance time relation or position time relation, that is S is equals to UT plus half AT square. Third is position velocity relation, S is equals to V square minus U square by 2A. Remember students, these equations are only valid if a particle is performing uniform accelerated motion. Now using these three equations, let us solve some numericals. The equations are V is equals to U plus AT, S is equals to UT plus half AT square, and third is 2AS is equals to V square minus U square. These are the very important three equations. Okay, now let us solve some examples. First of all, from your textbook, page number 108, look at this example 8.5. A train starting from rest. So it says that initially the train is at rest. So initial velocity is 0. Attains a velocity of 72 km per hour. So this final velocity is 72 km per hour in 5 minutes. So the time interval is 5 minutes. We have to convert this into seconds, and also we have to convert this velocity 72 km per hour into meter per second. Assuming that the acceleration is uniform, look at this, acceleration is uniform. So they are saying that the particle is performing uniform accelerated motion. So here we are allowed to use those three equations. Find, question number 1, the acceleration. First of all, you have to find acceleration, and second, the distance traveled by the train for attaining this speed. So according to given condition, example 8.5, initially the train is at rest, so U is equals to 0, attains the velocity of 72 km per hour, convert this kilometer per hour into meter per second. We know that we have to multiply this number by 5 upon 18. So 18 ones are, 18 fours are, so 5 fours are 20 meter per second. And the train attains this velocity in 5 minutes. So time t is 5 minutes. 5 minutes means 5 into 60 seconds. It is 300 seconds. First question, to find acceleration, means A is our question, and second you have to find the distance traveled by the train for attaining this velocity. So let us find first of all acceleration. What is the formula for A? A is equals to V minus U by T. Very easy. What is V? V is 20 minus U is 0 upon T 300. 20 minus 0, 20, 20 upon 300. 0 cancelled, 2 ones are and 2 15s are. So acceleration here of the train is 1 by 15 meter per second square. And now we have to find distance traveled. We have a formula for distance in these three. Look at this. we have two formulas connected to distance. S is equals to ut plus half at square. So if you want to find S from this formula, you should have the value of u, t and a. You have the value of u, t and a you recently found. So you can use this formula. Another formula associated with S is equals to v square minus u square by 2a. So v you should have, so you have v, you have u, you have a. So out of these two, any one of the formula you can use. Any one of the formula you can use. So let us use the last one. So S is equals to, we have a formula v square minus u square by 2a. Put the values, therefore S is equals to v square. V square means 20 square and 20 square means 400 minus u square is 0 square and 0 square is 0 divided by 2 into a. 2 into a we found as 1 by 15. So 2 into 1 by 15, here we have a, 1 by 15. Now, therefore, S is equals to 400 upon 2 and this 15 goes to numerator. So here 200 into 15. Therefore, S is equals to 15 2s are 30, 30 and 2 zeros 3000 meter. So distance travelled by the train to attain the velocity of 72 km per hour in 5 minutes, it has travelled 3000 meters. So we can say it's 3 km. This way, you first of all, whenever you are solving the numericals, you first of all read the question, make a list of given data. What is the question for you? What are the given things? You should know the equations. First, you confirm that whether the particle is performing uniform acceleration or not. If it is performing uniform accelerated motion, then only you can use these three equations. Okay, and then approach the answer. First of all, you make the list of data given and what to find. Then you should go for the formula. Next question number 8.6. Look at this. A car accelerates uniformly. Condition is given that here the particle is performing uniform accelerated motion. So a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Initial velocity is 18 km per hour. Final velocity is 36 km per hour. 5 seconds is the time interval. Then calculate first the acceleration and second the distance covered by the car in that time. Same type of question. Initially the car is moving with 36 km per hour. Example number 8.6. So initial velocity u is 36 km per hour. We have to convert this 36 km per hour into meter per second. 36 into 5 by 18. So 18 2s are 36. It's 5 2s are 10 meter per second. Final velocity attained by the car is 72 km per hour. Therefore, it is 72 into 5 by 18. So 18 1s are 18 4s are 5 4s are 20 meter per second. Car attain this velocity in 5 seconds only. So time t is equals to 5 seconds. And then then the question is you have to calculate acceleration and distance traveled by the car. A and S are again the questions for you. So we have a formula for acceleration. We can say A is equals to V minus U by T. Put the values. Therefore, A is equals to V is 20. Okay, so we have taken the wrong data. Initial velocity is 18, not 36. Here in place of 36, it is 18. So if you write 18 here, 18 will be cancelled. So the 5 meter per second it will be, and here it is 36. So if you take 36 here, it would be 10 meter per second. Please make it correct by yourself, it's easy. So what is V? V is 10 minus U is 5 and time interval is also 5 given. Therefore A is equal to 10 minus 5 is 5 by 5, it's 1 meter per second square. Okay, so acceleration is 1 meter per second square, and now you find S. You can find S by any one of the formula, but it's somewhat easier to use the last one. So S is equals to V square minus U square by 2A. Therefore S is equals to V square. V square means 10 square. 10 square is 100 minus U square. Value of U is 5. So 5 square 25 upon 2 into A. A we recently found as 1. So 2 into 1 will be 2. Therefore S is equals to 100 minus 25 is 75. 75 by 2. So it is 37.5 meter. So the distance travelled by the car is 37.5 meter. Easy sum. Next question number 8.7. The brakes applied to a car. Brakes are applied to a car produces an acceleration of 6 meter per second square. Here it's a tricky one. In the opposite direction of the motion. So look at here, the brakes are applied. So I think the simple logic is here that if the brakes are applied, velocity decreases, and if velocity decreases, the acceleration should be negative. So here it is given that 6 meter per second square in the opposite direction of the motion, and opposite direction means negative direction. So here the value of A is not 6. Here the value of A is minus 6. In the question, the minus sign is not given, but in place of minus sign, the words are given that in the opposite direction. So you have to take care that when you are doing the sum and wherever you see that particle's velocity is decreasing, you have to take A as negative. Okay, so here the brakes are applied. Retardation of 6 meter per second square is produced here. If the car takes 2 seconds to stop, means once the brakes are applied, car stops after 2 seconds. The application of brakes. Calculate the distance it travels during this time. Nice question. First of all, make a list of data. Example number 8.7. Okay, acceleration of 6 meter per second square means A is equals to minus 6 meter per second square. It takes 2 seconds to stop after the brakes are applied. So T is equals to 2 seconds, and it is given that the car is going to stop after the brakes are applied. So stop means what? So I think the final velocity is 0. Consider the situation is like this. Here is the car. From this point, the driver has applied the brakes, and after 2 seconds the car stops here. So initial velocity when the brakes started to apply is not given to you, but final velocity, because the particle is going to stop here, velocity is 0. So what is initial velocity? Initial velocity is the velocity of the car when driver started to apply the brakes, and later on the particle is or the car is going to stop there. So final velocity is 0. U is not given, but S is our question, that they are asking for the question that what distance it has traveled during this time. Which time? The time when driver started to apply the brakes until it stops. Okay, so in these 2 seconds, what is the distance traveled? That is your question. We know that there are 2 formulas regarding S. Let me write again. S is equals to ut plus half at square, and also S is equals to v square minus u square by 2a. So any one of them you can use, but look at this. If you use this first formula of S, because we want to find S here, then you should have the value of u, t and a. We have the value of a, we have the value of t, but we don't have the value of u. Okay, so let us check the third one, the last formula. If you want to use the formula of S, you should have the value of v, u and a. You have the value of v, we have the value of a, but again we don't have u. So it is necessary that if you want to find S, because you want to find S here, you must have the value of u. So we cannot find S without the value of initial velocity, and that is not given in the question. So first of all, you find the value of u. So which equation? The first equation, v is equals to u plus at. So from this, first of all, you find u and then you go for S. So from the first equation, v is equals to u plus at. Therefore, now what should be the formula for u first of all? So transfer this at from plus sign here in minus sign. So u is equals to v minus at. Now put the values. U is equals to, what is v? V is 0 minus. Now what is a? A is again minus 6. So it is minus 6 into t. T is 2. Minus sign of this formula and minus sign of the value of a. So minus minus plus. So therefore u is equals to 0 plus 6 2s are 12. So u is equals to 12 meter per second. So initial velocity of the car when driver started to apply the brakes is 12 meter per second. And now we want to find S. Now I think you can find S by any one of the formula. Okay, so again let us use the third one. So S is equals to v square minus u square by 2a. Therefore S is equals to v square. V square is 0 square and 0 square is 0 minus u square. U square, recently we found u as 12. So u square means 12 square and 12 square is 144 upon 2 into a. So 2 into a is minus 6. So 2 into minus 6. Therefore S is equals to 0 minus 144 means minus 144 upon 6 2s are 12 and minus sign. So it's minus 12. Minus cancelled. So 12. 12s are here. Therefore S is equals to 12 meter. So the distance traveled by the car before it stops from the point from where the driver has applied the brakes is 12 meter. So this distance will be 12 meter. Okay. So these are your examples from your textbook. Some blue color questions are there on page number 109. Let us do them. Page number 109. Blue question number 1. First one. Look at this. A bus starting from rest. Starting from rest means initial velocity is 0. Move with uniform acceleration. Okay, so they are allowing you to use those 3 equations of 1 meter per second square for 2 minutes. The bus starting from rest move with a uniform acceleration of, I think it should be 0.1. It's 0, 1. So I think let's take 1. Forget the 0. So 1 meter per second square for 2 minutes. Find the speed acquired and the distance traveled. See, we are not concerned with the value. Whatever will be the value, we just want to use, we want to see that how we can use the formula. Yeah, it is 0.1 meter per second square is the acceleration for 2 minutes. Find the speed acquired, means final velocity, and the distance traveled. The bus initially was at rest, so u is equal to 0 meter per second. Moves with the acceleration of 0.1 meter per second square for 2 minutes. So time t is equals to 2 minutes, and 2 minutes means 120 seconds. Find the speed acquired, means v is our question, and also s. So I think it's very easy. First of all, v is very easy to find. That v is equals to u plus at. Everything is there. Therefore, v is equals to u is 0, a is 0.1 into t is 120. So therefore, v is 0 plus 0.1 into 120 is 12. So therefore, v is equals to 12 meter per second. And then we have to find s. Okay. So you might be thinking that why sir is not using this formula to find s in any problem. Let us use it. Doesn't matter which formula you are using. Answer is a matter of concern. But you use this formula. It's very easy to use. That is why we are using this. It's user friendly. Otherwise, this also is correct. But it's very comfortable to use this formula. Second one, s is equal to ut plus half at square is very comfortable to use when u is 0. And here u is 0. Why? Because look at the formula. S is equals to ut plus half at square. Now put the value. S is equals to u into t. But here u is 0. So 0 into t will be 0. So it's 0 plus half at square, and therefore s is equals to 0 plus something means it is same, half at square. So formula becomes smaller if initial velocity of the particle is 0. Put the value s is equals to half into a is 0.1, 1 by 10 you can say, into t square is 120, so it should be 120 into 120. So 0 cancelled, and 2 6 12 6 are 72, and the 0 means 720. So s is equals to 720 meter. The distance traveled by the bus is 720 meters. Next question number 2. A train is traveling at a speed of 90 km per hour. So initial velocity 90 km per hour. Brakes are applied so as to produce a uniform acceleration of 0.5 meter per second square. So I think here the brakes are applied, so this acceleration should be minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. That is the same type of question as we have done before. Question number 2. The condition is that here the bus, for example, the bus is moving with certain initial velocity that is given as 90 km per hour. So u is equals to 90 km per hour. As usual, we have to convert it into meter per second. So multiply this number by 5 by 18. So 90 up into 5 by 18. 18 5s are 5 5s are 25 meter per second. train will go until or before it brought to rest. So distance is our question. But again it is given here that how far the train will go. How far means distance we have to find. So how far the train will go before it brought to rest. Rest means final velocity should be 0. That's all. And S is our question only. So you have U, V and A. So I think the last formula of S is very easy to use. S is equals to V square minus U square by 2A. Put the values. V square means 0 square is 0. Minus U square is 25 square 625 upon 2 into A. So 2 into minus 0.5. 2 into minus 0.5. Therefore, S is equals to 0 minus 625 means minus 625 upon 2 into minus 0.5, it should be minus 1. So minus minus cancelled, and therefore distance is 625 meter. Once you learn the formula, once you understand the question, I think these numericals are the damn easy numericals. Question number 3. A trolley, while going down an inclined plane, has an acceleration of 2 cm per second square. Here the acceleration is given in terms of centimeter per second square, so it doesn't matter for us. What will be its velocity 3 seconds after the start? Again in the question, a trolley while going down an inclined plane, the question is like this. Question number 3, page 110. One of the inclined plane is like this, and this is the trolley going down, okay, in this direction. So before it starts to move, its initial velocity is 0. That is the logic to be understood. It moves with the acceleration of 2 cm per second square, and they are asking that what would be its velocity after 3 seconds of start. So here its velocity is to calculate. So which are the informations? U is given as 0 cm per second. You can write 0 is 0. Acceleration is given as 2 cm per second square, and time is 3 seconds. And you have to calculate only V. So I think it's very easy to calculate. V is equals to U plus AT, the first equation. V is our question, so U, AT, everything is given. Then you just put the values. Therefore, V is equals to U is 0 plus A is given as 2 cm per second square into T is 3. So therefore, V is equals to 3 2s are 6 cm per second. So the final velocity after 3 seconds of start will be 6 cm per second. No need to convert this into meter per second, because centimeter per second is also the value we get. Okay. Next question number 4. A racing car has a uniform acceleration of 4 meter per second square. So acceleration is 4 meter per second square. What distance will it cover in 10 seconds after start? So after start means initially it is stationary. Question number 4. A racing car has a uniform acceleration of 4 meter per second square. So A is equals to 4 meter per second square. What distance it will cover after starts means U is 0 after 10 seconds. So T is 10 seconds. And what distance will it cover means S is your question. Initial velocity is given as 0. This is U. So we have two boundaries for S. S is equals to ut plus half at t square. I have told you that when u is 0, you can use this formula. It will be easier. S is equals to ut plus half at t square. Therefore, S is equals to u is 0. U is 0, so 0 into t would be 0. S is equals to half a t square. Therefore, S is equals to half into A. A is 4 into t square. T square is 10 square and 10 square is 100. 2 2s are. Therefore, S is equals to 2 into 100. 200 meter distance traveled. Okay. Last look at the question number 5. A stone is thrown in a vertically upward direction with a velocity of 5 meters per second. If the acceleration of the stone during its motion is 10 meters per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? A stone is thrown in a vertically upward direction. It's a very crucial example. Listen to me. Consider, here is the stone which is thrown in the upward direction. So we know that when we throw anything in the upward direction, its velocity gradually decreases of whatever the velocity you have thrown the particle here. It is given here that we have thrown this stone in the vertically upward direction with the velocity of 5 meters per second. So when you leave the stone from your hand, you have given 5 meters per second velocity. So here at this point. But as we goes up, its velocity decreases because it is going in the opposite direction of gravitational force. So its velocity gradually decreases. So whenever the velocity decreases, its acceleration should be negative. It is given in the question that acceleration is 10 meters per second square downwards. It is given in the question. You read that from your textbook. Acceleration of the stone is 10. It is given that 10 meters per second square in the downward direction. So when the stone is going down, its acceleration is 10. But here the stone is going up. So acceleration must be minus 10. So here question number 5. Look at the data. Initial velocity we have supplied is 5 meters per second. Acceleration is taken as minus 10 because it is the decreasing velocity type of motion. The question is, what will be the height attained? So up to what height means up to what distance will it travel? So indirectly they are asking for distance. Height means here distance. And how much time will it take to reach that? S is our question and also the T. And the only two informations are 5 meters per second initial velocity and acceleration is minus 10. We have three equations. V is equals to u plus at. S is equals to ut plus half at square and one more S is equals to v square minus u square by 2a. Out of these three only we have to find S and T. T is missing for the first time, I think. In previous all the numericals T was given, but here the new thing T is missing. How can we find T? Can we use second one? How can we find S? S is equal to ut plus half at square, but already T is missing. S and T, two missing terms are here in the first one. Second, V is equal to u plus at. So V is nothing missing here. U is given, A is here, T is missing. So in this equation also two terms are missing, and we know that whenever the two terms are missing in the same equation, we should not use them. Last equation, S is equal to V square minus U square by 2A. S is missing, V is again missing. So if you read the question carefully, here the particle is going in the direction upward. Here the velocity is 5. As it goes up, velocity decreases from 5, let's say it's 4, then 3, then 2, then 1, and at last moment, its final velocity becomes 0. So here we can say final velocity is 0 meter per second. So in the sums of retardation, previously we have solved 2 or 3 different sums of retardation in which the acceleration is negative. So in all those questions, if we have marked, normally the particle stops there. So if the particle is going to stop, its final velocity would be 0. See, we are talking about the upward motion only. In practical, we know that when we throw the particle in the upward direction, it goes up to certain height and then it comes back. But we are talking about the upward motion only because we have taken the acceleration is negative. So we are only talking about the upward motion. Here the velocity was 5, 4, 3, 2, 1 and finally its velocity becomes 0 for a moment. And then the stone started the return journey, but that is the different motion, that is accelerated motion. That we are not going to discuss. We are talking only this upward motion. So in that case, V is 0. And now once you find V, I think you can use this formula. V is equals to U plus AT. You can find T. V is 0 is equals to U is 5 plus A is minus 10 into T is missing. Therefore, 0 is equals to plus minus minus, so 5 minus 10t. Therefore, minus 10t is equals to, let us take this minus 10t here, so it is plus 10t, 10t is equals to 5, therefore t is equals to 5 by 10, so it is half, so it's half second. So T we found, and now let us find S. S is equals to, here U is not 0, so I think we should use the last formula. S is equals to V square minus U square by 2A. Therefore S is equals to V square is 0 square and 0 square is 0, minus U square is 5 square 25 upon 2 into A. 2 into A means 2 into minus 10, it's minus 20. Therefore, S is equal to 0 minus 25, so it's minus 25 by minus 20. Okay, so 2 10s are and 2 12.5s are. So 12.5 upon 10 minus minus already cancelled. So therefore, S is equal to 1.25 meter. So the distance traveled by or the height attained by the stone is equals to 1.25 meters. Is that clear, everybody? So this is all about the numericals regarding uniform acceleration. Okay. Be practicing. We have still some numericals to solve from exercise if they are, but that will be in the next session. Best of luck.